Hello, my name is Bobby and I am your data guy, and today we're going to walk through how to use Microsoft Fabric Analytics, and we're going to take data from OLTP databases and pull them into Fabric to create a gold level data warehouse. Let's get started. So today we're going to look at Microsoft Fabric Analytics. This is going to be a walkthrough to show you how to take data from your OLTP database and bring it into Fabric and use data warehousing techniques to get to the gold level. I'm going to explain all about what that means. First, we're going to go through some key concepts in this short slideshow, and then we're going to do a hands-on walkthrough. All right, first, just some background on Microsoft Fabric. So this is an end-to-end analytics platform that allows you to unify all of the different aspects of your data warehousing. So data movement, processing, ingestion, transformation, real-time events, and reporting. You can do everything that you could possibly need here in the Fabric ecosystem. This is built on a SaaS foundation, integrating all of the different services that you may be familiar with if you use Azure for data processing. So Power BI, Synapse Analytics, Data Factory, and a bunch of other services we're going to walk through. And the key core element here is that Fabric centralizes all of your data in what's called OneLake. As well, then they embed AI capabilities like Copilot on top of all of this data. At the end of our process, we're going to have Power BI reports that allow us to do visualization and share data across our organization. In order to build that out, we're going to replicate our OLTP data into a Fabric mirrored database. We'll use Data Factory and certain pipelines in order to ingest and run stored procedures or materialize views in our data warehouse. We can also do real-time intelligence, which is event-driven data handling in Fabric, though we won't be discussing that in this demonstration. Furthermore, we can do data engineering and data science using Spark-based processing and machine learning models. Again, that will be outside the scope of this course. What we will be looking at is how to build high-performance SQL data warehouses that use the data lake format. And really, the data lake format and all of Fabric is centered on this concept of OneLake, which is a unified data lake for all organizational data. Here you can see all of those different services sit on top of OneLake. And OneLake is a file store using a Delta Parquet format files. And that's how we ingest all of our data from our external sources, centrally located in the OneLake. And then all of these services can use that OneLake data store, which is built on Azure Data Lake Storage Gen 2 technology, in order to build out all of the different analytics that we're going to prepare. So OneLake is at the core of everything that we do here in Fabric. Here are some Fabric benefits. By using Fabric, we can streamline workflows. So we're no more stitching tools together. Everything's now in one place. We can use AI-powered efficiency, so Copilot is built into everything that Microsoft has these days. We have centralized governance. This means easy data sharing, but while maintaining security and compliance using Purview integration. And this is scalable for SaaS, so this handles real-time analytics on SQL data without heavy infrastructure. And that's one of the benefits here, is that we don't need to build and maintain a bunch of infrastructure in order to get started in data warehousing. Here's a visual of the data warehouse that we're going to build today. What you can see on the far left is the OLTP database. So this is online transaction processing database. This is our transactional data from our production system that our SaaS, our software sits on top of. Using different techniques, now today we're going to show mirroring, but you can also use copy or replication. We can move our OLTP data into the Microsoft Fabric ecosystem and have a copy that's kept up to date in real time with our data. We'll apply row-level security on top of that. And then we have some different data warehouses here that we'll build out to build different layers of analytics. Now you can see here I've marked these with bronze, silver, and gold. That's one technique of data warehousing, where bronze is just the raw copy of the data. It's an accurate and valid copy of our data. The silver version is going to be where we apply views and stored procedures on top of our bronze data. And this makes it ready for data analytics. So we can do some data analysis in Power BI or maybe in Python code if that's our preference. But the silver data is where we then have a copy of what we're working with. But then our silver layer is ready for analytics. And the gold layer takes that another step and goes a little bit further. That means that we're ready for machine learning. We're maybe aggregating our data directly in views and stored procedures as well. So we don't necessarily need to get to gold. That is going to be our desire, but we at least need to get to silver in order to do some top-level analytics on this data set. And then finally, at the bottom, we can see some of the different outputs. So we can build paginated reports, Power BI embedded, so we can actually embed our analytics back into our application. Or we can run copy jobs, which are pipelines in Fabric that allow us to export our data to additional data stores. And finally, we could build a GraphQL API on top of our data set so that other services outside of Fabric can now consume all of this enterprise-grade, analytics-grade data. All right, why do we want to mirror data in Fabric? Well, there's a few reasons. The approach that we're taking here is to use the database mirroring function in Fabric. The reason we want to do that is that it's low cost and has very low latency. And for replication, it's going to have a very low impact on our production database as well. This is going to convert all of our source data into that Delta Lake format that we talked about earlier, enabling all of the services in Fabric to now have access to that data. And then finally, this is fully managed by Azure and the Microsoft Fabric ecosystem, so we don't need to worry about syncs failing or how to fix a bad sync or anything like that. It all happens directly in Fabric. So how does it work? Well, first, Fabric will establish a secure connection to the source database. It will replicate both the data and the metadata in near real time, and we'll talk about what that means in a slide or two. There's 3 different ways that we can mirror the data. Today we're going to do full database mirroring, which means we're copying one for one all of the records from our source database into Fabric. But we can also use metadata only via shortcuts, which just copies the metadata but keeps the data actually in the source database. Or if we have an open mirroring formatted database, we can also use open APIs to consume that data in Fabric. So again, we're going to do full database mirroring here. This integrates with Fabric services. So now we can query this data via SQL, Spark, or Power BI without moving the data any further. Once it's in our Fabric ecosystem, we'll have access to it with all those services. Here's some supported sources, so Azure SQL or Azure SQL managed databases, or what's more likely is that you have an on-premise SQL server. Now, this could be a virtual machine that you manage in the Azure ecosystem or an actual on-prem virtual machine or appliance that you're running SQL Server on. We'll need to use SQL Server 2016 or newer in order to mirror the database. We can also consume data in this way from Snowflake, Azure Cosmos DB, or another handful of other sources. Today, though, we're going to be using an Azure SQL managed instance because that's going to look and act the same way that your on-prem SQL server or your virtual machine in the cloud SQL server will act. The benefits to mirroring our database is that now we're eliminating silos. We're going to have near real-time access for business intelligence and AI on top of our operational data, but we're not going to bog down our transactional database with those analytics queries. Analytics queries can be very heavy and consume a lot of resources on those production databases, and so we want to avoid impacting those production databases as much as possible. This is cost effective because once we've built our Fabric ecosystem out, the compute is going to be shared amongst all of the different resources that are running in Fabric, and so this replication will just be another instance or another demand on that compute that we're already paying for. Okay, so how does it work? For SQL Server, we're going to activate a feature called Change Data Capture. From the Fabric perspective, Fabric supports mirroring data from the 2016 through 2022 versions of SQL Server. Now, a job will run every 5 seconds that scans the transaction logs of the server and writes a change data capture change table entry for each change. This means that a table is created alongside every table that we have in our database, and that table is called a change data capture change table, and it's going to include a record of every change that's made in that table. These records do get truncated as the sync as the syncs occur and as time passes. So don't worry, you're not going to bog down the storage in your database by having these tables active. That's something that we'll need to plan for. So we want to test this in a development environment first before you roll this out in production. Make sure you have 5 or 10% headroom on your compute. As well, make sure that you've got, let's say, another 5 or 10% headroom on your storage. We plan that change data capture will consume, on average, around 10% of compute and file storage. That's worst case scenario, but it's something to plan for. So take a look at your current utilization of your database and make sure that you have enough room in order to make this change. Once we've activated change data capture, we're now going to go to Fabric and set up the database mirror. Initial replication is where Fabric will copy all of the contents from all of our production tables. And then moving forward, we'll conduct incremental syncs. And the incremental syncs is where Fabric will come in and frequently check the change data capture change tables for any updates. The interval is unknown as to how often that polling occurs, but just know that data is typically replicated within seconds or within at most a couple of minutes. So this data in our Fabric instance will be near real-time accuracy. If you need analytics that are more accurate than a minute or two, then this is not the right tool for you. Some questions I've got about this, and I just want to clarify, there's a few different ways that you can move data from your production databases into Fabric. We've got mirroring, which is what we're going to be doing in this walkthrough, but there's also SQL Server replication and Fabric copy jobs or copy activities. So here's a way that you can compare them. The keys here that I want you to pay attention to are latency. So for Fabric mirroring and SQL Server replication, we consider those both to be near real time. The performance impact for Fabric mirroring is considered to be low on your source database, whereas SQL Server replication, we consider it to be medium. And the reason is that there are agents that run on the SQL Server for replication that are constantly checking tables to see what new records have come up, and then those records are pushed into the destination table. That compute, the compute that those agents consume, resides on the same device, either virtual machine or physical server, as the actual SQL Server itself. So there's a resource contention there between the agents that run checking to see if data has changed and the actual SQL Server. So that's why we consider Fabric mirroring to have a lower impact on source. In either case, they're going to be using the same form of scanning transaction logs and keeping a record of changes. Fabric copy jobs typically use a specific column, like a date timestamp column, to understand what's changed since the last time the data has synced. That can also cause a little bit of a higher demand on the database, and so that's just something to be aware of as well. All right, now it's time to build. So let's go through the walkthrough. Here's the SaaS application data model that we're going to be working with today. We have a few different tables to walk through. So first, there's a users table that has one record per user with some user information. We have a plans table. These are different plans that users can subscribe to. Both of those tables have a one-to-many relationship with our subscriptions table, which is a record of all of the different subscriptions that exist in our system, pairing both users with a plan, one or many plans. And then finally, in order to keep subscriptions current, we have a payments table, which has a one-to-many relationship from subscriptions to payments. So we'll have many payments for each individual subscription. Finally, down here at the bottom, we've got some additional transactional tables that we want to pay attention to. We've got application usage and support tickets. So as users use our application, their usage will go up, and we'll see more records in that table. And as they submit support tickets, we'll also see that in our support tickets table. All right, and here we are in Azure. On another screen, I've got a script running, a Python script, that's generating random data every 3 seconds. And so what's happening now is additional records are going to continue to be entered into this database while we're working through this system. The first thing we want to do is head over to Power BI and establish a new workspace. So I'm going to come here into my workspaces, select new workspace, and this is going to be our Fabric demo workspace. We're going to assign this to our trial fabric capacity. If you already have a fabric capacity, then you'll want to just assign this to that fabric capacity here at the bottom of that screen. This will give us all of the features that we're looking to demonstrate here. In order to connect to this SQL Server or any SQL Server, we need to download and install the on-premise data gateway. In order to do that, we need to download the standard gateway and install it. It's a fairly straightforward install process. The on-premise data gateway needs to be installed on a device that can access our SQL Server either on the same network or on the same appliance. It's recommended for resource contention that the on-premise data gateway just runs on a separate virtual machine that is constantly available and running on the same network as our SQL Server. All right, and now we're in the Fabric workspace. So let's go through the process of setting up our database mirror. In the top left corner, we see this New Item button. That's going to pop out a pane that shows us all of the different services that we can activate here with Fabric. We're going to be looking for mirrored Azure SQL Managed Instance. That's what I'm running for this demo, but you will also see mirrored SQL Server and all of the other different databases and sources that are supported for mirroring. And now we need to set up a new Azure SQL Managed Instance that's connected to this environment. All right, Fabric's connected to our SQL database, pulled all of the tables, and now we're ready to create our mirror. Now we're going to give that mirror a name. We'll call it Demo1 Mirror. And we click Create Mirror Database. And now we wait while the mirrored database gets set up, as well as all the other services get spun up for this. All right, and our data sync is running now. This is the initial replication where all records from the database are going to be synced into Fabric. All right, and all of our records have been synced into Fabric. See the row numbers here. As well, we can see that this is now perpetually running. As a reminder, I have a data generator running in the background, and so what we'll see is that over time, these counts are going to slowly increase. Specifically, we should watch payment and usage row counts, as well as the last completed timestamps. And there you are. We saw one record, additional record here for you. All right, and now we can see data being mirrored into our environment. So if we look at payments and usage, we can see these numbers of rows replicated and the last completed timestamp continues to increase over time. The last time a new record was inserted for plans was 12:28 p.m., whereas all the other tables received new records at 12:44 p.m. That's because we've got a script running in the background that's generating that data. All right, so this covers the first step of getting our OLTP data into the Fabric environment. Next, we want to create a data warehouse that sits on top of this data and allows us to start manipulating it and prepare it for analysis. All right, now that we have our data in the mirrored database, we are going to create a lakehouse. Now the lakehouse is the best option if we want to leave the data in that mirrored database but start building views and additional tables on top of it. We're going to use something called a shortcut, which essentially will point from our lakehouse into the mirrored database without copying any of the data. So this is not another timed process that's going to increase latency of our data. It's going to reference the data directly in the database. So we're going to look for Lakehouse here in the new item menu. This Lakehouse is going to be our silver level. And we're going to use Lakehouse schemas. So make sure to check that box because that will allow us to automatically detect the schema of our database and import the tables from the database. All right, so here we are in the Lakehouse. Under Tables DBO, we're going to click the three dots and create New Table shortcut. And we'll select internal sources, our OneLake. So that's where all of our data is sitting right now in that Demo1 mirrored database. And now we just need to select all of the tables that we have in that database. These again are shortcuts, so they're just pointing to the data in the mirrored database. We're not copying any data, but it is recognizing the schema of that database. All right, and now we can see our data in table form in the Lakehouse. Now there's two ways to view this. We're currently in the Lakehouse view to explore data files and folders, but really what we want to do is view the SQL endpoint. And that allows us to interact with this data. Though it's being stored in Parquet files, it allows us to interact with this data in more of a SQL-like manner. So we'll see all of the tables now. The next step that we want to accomplish is to apply row-level security to these tables. So each user should only be able to see the data that is pertinent to their user ID. So we're going to create a new query. So right-click a table, go New SQL Query, select Top 100. And now this is a SQL writing experience. I'm going to copy and paste in a script, and this script creates functions. So for our row-level security, we have functions. Those functions compare the currently logged in user with a user in our users table, and then filters the data accordingly. And it does it for every table in our database. And in some cases, it'll do a join to get us to the specific logged in user and what plans, subscriptions, maybe support tickets, and so on that user should be able to access. Now, something like plans, everyone can view, so we might not necessarily need that filter. But for subscriptions, the logged in user should only see their subscription. Same is true for support ticket and usage. One way we can test this is just to select username. This will make sure that we can properly retrieve the identity of the logged in user. And there we are, it shows my email address. All right, so now we're going to run this script. That's the error we're looking for. Okay, so what's happening is that there's two different ways to access our data, and it depends on how we've built our user identity or how we're sharing our user identity. We can access our data via the SQL endpoint, but before we do that, we need to turn on the OneLake security. And what this is allow us to do is apply row-level security to this data structure. All right, once OneLake data access has been turned on, we're going to flip in the top right corner from the Lakehouse view to the SQL Analytics endpoint. This will allow us to write and run SQL queries. And then we need to change our mode of access so that when we apply our row-level security, it actually works based on our current logged in user. So in the top left corner, click the Settings gear and look for Data Access Mode. Now in here, we want to switch from OneLake security for tables to SQL security for all objects. And this is going to use what's called a Delegated Identity Access Mode. So we're going to click Apply. All right, now there's our delegated identity. And finally, we're going to run this script, which is a series of functions that filter each table based on the user's current logged in identity. So now if I click on users, for example, we know that there are a lot of users in this table, but I'm only able to see the one user that I have access to. If I look at plans, I'm also only going to be able to see the plans that I have an active subscription for. You can also see subscriptions, again, are filtered just to the user ID of the logged in user. All right, so row level security is now active on this endpoint. In our silver layer, we want to add some views to do some aggregations and filtering on the data set. So go ahead and go into the SQL Analytics endpoint. We're going to create new shared queries. This will be a way to capture the definitions of these views and share them with others. I'm going to paste in the definitions of our views here. There's two of them: user subscription details and monthly revenue summary. And I'm going to rename this file over here. And these will be our demo views. And then we'll run this script, and now we'll see the views in our data set. And you'll see that these views are also respecting our row level security. Next, let's build a semantic model on top of our silver layer. This will allow us to create Power BI reports as well as paginated reports. So in the top bar here, I have new semantic model. We can see all of the different tables. We're going to include all tables and our views. And we're going to give this model a name. When I click confirm, the model will be created. Now, because we're using row level security within our lakehouse, we're going to have to use direct query in the semantic model. Now, if we look within our workspace, here is our model. All right, now in this semantic model view, we want to properly model the relationships between these different tables. And for now, we're going to ignore those little errors that are popping up, and we'll deal with those in a bit. So all user ID columns should be connected. All right, so we'll go up to the top right and click Edit. We'll put this in editing mode so that we can create the relationships. We have user ID in many of our tables, so we're going to create those relationships first. And now plan ID, or plans to subscriptions, and subscriptions to payments. Our error says DAX queries may fall back to direct query if allowed or show errors. To fix this, try refreshing the semantic model, scaling up the capacity, or avoid using SQL endpoint items such as views. And that's because we have two views over here that are also included. Or it's potentially due to other things that we're doing here. Direct query mode will be fine for us. As opposed to right now, the tables are in direct lake mode, which is another way of pulling the data. So we just need to convert this to be a direct query call, and this will be fine. All right, and finally, let's build a report off of our model. Okay, and here's our report. Let's see what the amount is. Amount comes from payments, so that's how much was paid for each plan by the logged in user. Remember, this is also using our SQL row level security. Next, let's look to see how we can create paginated reports based off of this data. So we click the New Item button in our workspace and go to Paginated Report. We choose the data model that we want to use. And now we're in an interface where we can pull in fields. For example, let's create a table that shows username and email address, as well as the plans and payments. And there we can see for the logged in user, all of that data. We can save this. And then when we switch to the view mode, we can set up a subscription for this report. So as more data comes in, or on a weekly or monthly basis, we can schedule this report. Paginated reports are great, especially for really large data sets, because it'll give you multiple pages of your data, as opposed to exporting a Power BI report to PDF where it just takes a screenshot of only the visible data. This will give you all of your data. So this is a good way if you need kind of a way to structure data that's being output to CSV and then have it emailed to you. That's a good way to do that. But I'm going to show you one more thing that we can do in Fabric that allows us to export data in a secure way. All right, so in order to export data in a secure way, we're going to go back into our workspace and we're going to build a copy job. So we're going to look for copy here in the new item window. And all of these are the same. We just need to choose one of them. And we're going to copy to Azure Blob Storage. You could imagine that this is an FTP site or bucket. This is an S3 bucket's another option. And this would be a good way to structure a very large amount of data being exported from the system. So within the copy job window, we can see we have different data sources. We always want to be really consistent here and stick with Silver Demo 1 as our lakehouse. That is our silver level analytics layer. And we're going to select a few of these tables. Well, let's select all of them. And now we need to choose a destination. We can copy this data to other SQL servers. So if you have external SQL servers that you want to push this data to, that's an option. Or in this case, what we want to do is set up an Azure blob to connect to. And we don't have one connected now. All right, we're going to paste in the endpoint URL here. We'll leave data gateway to none because this can be accessed via the cloud connection. For authentication, we're going to use account key and paste in a key. Right, and then we'll determine exactly how we want to output that data. Because this is a file storage, we can decide if it's a text delimited, maybe a JSON file, or a Parquet file. Text delimited can be text or CSV type files, and whether we want headers included in that file. All right, we'll just call the folder demo 1. And I'm going to give these CSV file names. All right, we'll do a full copy. Now we have the option for running this once or on schedule. In this case, I'm only going to run it once for the demo, but you could set this up on a daily or weekly schedule. All right, and we save and run. All right, and the files have been placed now in that demo 1 folder of the storage that we were using, and we can download them and check them out. And as we would hope, they are indeed CSV comma separated values files. All right, and finally we need to flesh out our data analytics strategy by getting to the gold level. The gold level include views and stored procedures that are going to generate tables that we can pull into our analytics tools or use for machine learning. You have two options in how you want to build these and how you want to maintain them. Depending on your silver level lakehouse, if it's full of queries, if it's already complex enough and you want to actually build on top of those queries or some of the results, then we can build a new lakehouse called the gold lakehouse. And that gold lakehouse then would have these additional views or queries or tables. Especially if we want to limit the views or tables that the end user has access to when they're building out Power BI reports or doing machine learning, then building an additional lakehouse, only pulling in the values or the tables and the stored procedures and results that we need and caching that there, and then only sharing the results from that gold lakehouse is a good way to maintain or manage control over our data. So let's go ahead and do that now. In order to copy the results of a stored procedure into one of our tables in one of our lakehouses, we need to run a pipeline. So we're going to go to New Item and look for Pipeline. And in this case, it's going to be our stored procedure to table. All right, we'll go to Activities along the top bar and look for Stored Procedure. That's going to put a little rectangle on the page here that we can then use to configure all the details about running our stored procedure. On the Settings tab, we need to select a connection. And we'll want to find the connection for our silver lakehouse. All right, if we need to materialize views for a stored procedure in our lakehouse, either in the silver or gold layer, we're going to use the copy data function here in pipeline, in our Fabric pipeline. So we go up to copy data and say add to canvas. This adds a copy data activity on the canvas. And our source is going to be the SQL Analytics endpoint. So something to keep in mind here is that the SQL Analytics endpoint is read-only. So we can only read or pull data from it. That means we cannot use stored procedures that have their own table actions, like dropping tables or creating new tables. What we want to do then is have stored procedures that just run analytics and return the results that we're looking for. And we'll use these copy actions to then copy those into destination tables, either in the same lakehouse or lakehouses further down the line, silver to gold and so on. So in this case, we're going to select this endpoint, which is our SQL Analytics endpoint, and we tell the system that this is an Azure Synapse Analytics endpoint. It'll show us our database, and we'll select Stored Procedure. In the drop-down, now you'll see it's loading all of our stored procedures. So we'll choose the top one, Get Support Tickets by User Silver. And under Parameters, we're going to click Import Parameter. So then it's going to review the code for our stored procedure and determine which parameters we need to pass. In this case, I'm just going to put a static user ID of 1, which is my user ID in the system. But of course, we can update that to be some sort of a dynamic value. And of course, this is an Azure Data Factory type flow, so we can do a lookup for specific user values and connect those in and use those variables here in this flow as we need to. All right, so that'll execute that stored procedure. Now on the destination side, we need to select the Silver Demo or Gold Demo 1 Lakehouse as our destination. So we're going to click Silver Demo 1, and we're going to create a new table. Give it a schema and a table name. This is our stored procedure results. And then we can select to append, overwrite, or upsert. In this case, we're just going to overwrite. When I click Run, we'll save the pipeline and run it. And while that runs, we'll head over to the Silver Lakehouse. so we can see all of the tables that we have. Now you can see here I have a stored procedure test table that I created previously. This gives us a cleaned up view of our data. And then we can refresh this and we're going to see that new table pop in here in just a moment. SP results. And there are the results of that stored procedure. An alternative to stored procedures would be to use the new materialized lake views. Let's check it out. So here in our Silver Lakehouse, in the Lakehouse view, along the top, we have this Manage Materialized Lake Views button. This will show us any materialized lake views that are already created. Materialized lake views are like storing the results of a view in a table so that it doesn't need to be recalculated every time someone pulls that view. In this case, we're going to click New Materialized Lake View and a new notebook. This creates a notebook that we'll need to use to create our materialized view. And you can see the syntax here. It starts Create Materialized Lake View. Then we give it a name and then as a select statement. So let's give it, I'm going to put a prefix on it for MLV, which is Materialized Lake View, instead of just VW for view. And then we're going to copy in our select statement here, which does a join, also has a filter. When I run this notebook, now this materialized lake view is going to be recognized within our environment. These would be a really effective way to avoid having to create stored procedures and running lots of copy jobs that run your stored procedure and push it into a table. This way, your view will just stand as the way to capture the results of that data. And then you can trigger a refresh of the materialized lake view very easily. There's our materialized lake view. Now I can schedule it easily within this interface. And you can see here I've already set it up that every 15 minutes this view is going to be updated. Assuming that it's a long-running query, that should be more than enough for what we're looking for. To refresh the materialized view, we need to go back into our notebook. Let's add a new row. And you'll see here, this is the Spark SQL to run to refresh our materialized lake view. So let's grab the name. Full is a way to force it to refresh all results, whereas if we leave full off, Fabric will decide whether the data has changed or not and make its own decision whether it actually needs to refresh. That's a good way to save some compute if you're constantly running stored procedure jobs that you may or may not need to be running. And now we just need to run this cell. And what's cool about this is we can see now that the materialized lake view actually shows up as a table here in our schema. But let's let this finish running. We can see all the jobs that are running there. And we have successful completion. Another way we might want to consume this data is via GraphQL API. We'll pull this data from the silver layer of our data model. When I open up that analytics endpoint, you see there's a button here at the top called New API for GraphQL. We'll create a new API endpoint. We'll call it entire model because we're going to include every endpoint or every table in this endpoint. That also includes the views. What's great about the GraphQL endpoint is that it does respect our row level security. So users will have to sign in with their Azure Active Directory account, present that credential, and then based on that credential, we'll do a lookup in our tables for their email address and filter the tables accordingly. You can see here in the generated code that the first thing that happens when we run this code is get interactive browser credentials, and then to use those browser credentials as a bearer token when hitting the GraphQL API endpoint. Just to edit the fields that we're querying in this query right here, we just go in this window and type in the names of those fields. By selecting the table, that entity with all of its fields are automatically included within the endpoint. We can see all of the usage pertaining to the current logged in user ID number 1. So there's that row level security in action. All right, so we've been through quite a bit here. We first started off by taking our Azure Managed SQL Server database and mirroring it into our environment, into our Fabric environment. Then we built a lakehouse on top of that, applied row-level security so that all users that are accessing data can only see the data that they're supposed to. Then we went further and built views and stored procedures within our lakehouse that will provide us refined views of our data at the silver layer, which is just good for analytics. We also built a GraphQL API on top of that data model so we can consume all of this data in external applications. We looked at copy jobs to take data out of our silver layer analytics and move them into SFTP buckets, blob storage, S3 buckets, and in other destinations in either JSON or text formats like CSV. And then we also built pipelines that would create pre-aggregated views of our data. These are typically long-running views that we don't want to leave as a view, but we actually want to materialize as a table in our system. And so then we built the pipelines that would copy the results of those jobs into materialized tables in our data set. And we also, there's so much, we also built a Power BI semantic model and a Power BI report, and then finally a Power BI paginated report. So we built so much just based on mirroring our data into Fabric. And once we had it in Fabric, we really could do everything that we needed to. What's also nice about this is we could even invite our fellow employees or customers into this data environment, and they would only see the data that they should have access to, assuming that we limit their visibility of the mirrored data set, because the mirrored data set does not have row-level security, but everything else above and beyond that did. And that was the key. So keep those things in mind. I hope this video was super informative. I hope you really enjoyed some of the hands-on and the theoretical nature of what we're building when we're working in Fabric. And if you have any questions, feel free to reach out. My name is Data Guy Bobby. You can find me on LinkedIn and X. You can also send me an email at bobby@phoenixdata.works. I hope that you found this informative. I hope that you reach out if you have any questions, and if you need work, either contract or project-based, we here are standing ready to help. All right, thank you and God bless.